Hello, can you see the screen?
Yes, sir.
Hmm. So, what we discussed in our last lecture is that multi-threading can be implemented in Linux, and as we found that there are first is the NPTEL library, and this NPTEL library, it will provide the details implementation of how to create a thread, how to synchronize threads, how to exit threads, and all the details. So these are there are system calls, and what we found is here it has used the clone system call in some form, and mainly uh, the use of the different options, the flags through which we can create a new instance or a new executable instance which behaves like a thread. And when we call it as a thread, that means the process ID should be same as the parent ID. However, it will have a different thread ID, or in other words, we call it as lightweight process ID. That will be different. So we found that how we can tune those flags. Here, these are the flags to create exactly that what we want. But if we use the flags in different order or different combination, we can end up with uh, creating different types of executable instances. So which is not exactly the way we define threads. So right now let us restrict our discussion to the creation of threads using clone. So we have already found that how it can be done, and now I'll execute those codes and we'll see that how exactly this is done. And we must know that if I use different options, so it's not thread, but some different execution units will be created. Now once this is there, NPTEL is there, now we know that there is pthread library. Pthread library, it's basically a user level interface, it's a interface, so which basically use this NPTEL, and it implements a standard. So it has got a standard interface, and this pthread, instead of creating or calling clone, this will call some library functions. Say for example pthread, say here, so it is pthread create. So this pthread create, if we call it, we know that internally it will call this clone system call to get our new thread created under the calling process. Okay, so it will have so it's for creation, it will have a library, it will have a library function. Now it will have another one for terminating that thread, or closing that thread. So for thread termination, it will have pthread exit. And for thread synchronization, that means if this is the original parent thread, and if it has created other threads like this, so I want these small these child threads to join to this parent thread at some point of time. Got the point? So for that we have got so parent synchronize with the child threads. So for that we have got this function pthread join. Okay, so the point is these library functions are more readable, and maybe we can say it's more simple to use, and it also having a standard interface, so that if you using pthread library any application that is portable from in one machine to other, you can compile and you can run it, because internally when it compiles it will call clone according to the kernel versions and all, and actually a thread gets created and it gets tracked by the kernel and everything runs accordingly. Okay, so this is a user level library and this nptel. So this is what the internal story is. Now as we try to create lightweight process, so while creating a new process, while terminating a process, and also while the parent process wants to synchronize with the child, we had some system calls, right? So can you tell me the analogy of these pthread create, exit and join with respect to process? What are the equivalent system calls that we have? Pthread create is equivalent to what in terms of process creation?
Fork.
It is fork, right? And what about this pthread exit? So this actually triggers an exit or termination of a thread. And what is the equivalent which creates a termination of a process formally?
Kill
What is that?
system call.
This is exit, right? There is an exit system call that we discussed. So something equivalent to exit in a process, we have got pthread exit. It's for thread exit. Okay, and what about this pthread join? What is equivalent to this in terms of process, parent child process synchronization?
Wait system.
It is a wait system call. So can you see the analogy? So we have got the fork. Instead of fork we have got pthread create. We have got the exit, but instead of that pthread exit we have got the wait. Instead of that we have got the pthread join. So these are equivalent but not so their functionalities are not exactly the same, because terminating a thread and terminating a process will not have the equal amount of overhead, because thread itself is a lightweight process, and terminating a thread does not mean that you have to terminate the entire process, because it is just terminating a particular maybe a small portion of it. So it is something like if I terminate this one, that gets off, but still the process is there, or I terminate this child thread like that. Okay, so this is the equivalence, and apart from that there are other useful functions that is available in pthread create. So we'll look into the details of this, at least few of these functions, but there are many of them, plenty of them. So one point is when we have parent thread, say this is a parent thread. Okay, so this is a parent thread that is continuing. So these are all happening within a particular process. Now the parent thread at this point, it calls pthread create twice, and it creates these two child threads, maybe marked in blue. Okay, so now at this point, as like calling fork and then trying to synchronize using wait. So you can, if you can recall, fork and wait. So somewhere we call fork here, and somewhere later on we call wait. So here we call so the parent thread or the parent thread code, it executes pthread create here, does many other things as it requires, and then it calls pthread join. and once it calls pthread create, there are child threads created here, and each of the child thread, whenever they get their task done, so where this entire code will be written in a child thread, what to execute, where we'll find it, how a child thread knows what to execute, what we discussed. Hello?
The return value.
No, I mean, where should you place the code that the child thread should execute? I think I have mentioned that there should be a function. So every thread, we'll see the details here. So whatever a particular thread, a child thread need to execute, need to be uh, placed in a suitable function, in a function, and then when you create the thread, you have to pass the function name. So this entire logic, what the thread will actually execute, will be placed in a certain function, and this pthread exit probably will be the last statement that the child thread will execute in both the cases, if it wants to exit in a proper way. Is that fine? Hello?
Yes, sir.
I will see in details, but let me give you the overview of it. So the point is, this parent thread was executing, it created and it executed, and then it was, so at this point when it executes pthread join, it will be in a blocking state. If by the time it has executed pthread join, if none of the child threads has terminated, either normally by using by calling pthread exit, or by I mean, if the function returns, or if the function execution is complete, then also this thread has been will be terminated. So whatever way it is, if it executes pthread exit, uh, if the parent waits for it, it will try to synchronize, somewhat similar to that of wait system call, and after it has synchronized properly with it, then it can again continue running like that. So if this happens, this is one option, how a parent thread will synchronize with the child thread. This is one option. The other option can be the parent thread creates a child, here two child processes, child threads 1 and 2, and the child threads, they exit at these points, but the parent thread never executes the pthread join library function, right? Or in other words, something similar, where the parent process forks 2, 3 or multiple children, but it never executes a wait system call. So in that case, what happens? The child threads keep continuing. If they want to exit, they will exit, doesn't matter. So here, after creation of the child, the parent is no longer attached with the child. So it is not interested in getting any kind of attachment with that, because it has not executed any join statement, join function. The pthread join is not there, but in this case it is doing that. So that's why there are two types of threads, we say. One is the joinable threads, one is the detachable threads. So in a detachable threads, a parent thread creates a child thread processes, child threads, and it simply forgets about that. So whenever the child thread wants, I mean, uh, it may continue for any amount of time, and when it stops, it stops. So the parent does not care about the child thread execution, termination, anything. Okay. So whether, I mean, if you want to create, when you are willing to create a thread using this pthread create, you can have the option to specify whether the child thread that I'm creating will be a joinable thread or detachable thread. So this attribute, this second argument, which specifies the attribute, so this actually So here you can place that option. So whether you want to make it attachable or detachable. Okay, so this is important. And this pthread id, like every say, like when you create a process, a child process is created. Now the fork returns the child process id, right? The child process id that get created, it will be returned by the fork. But when you create a child thread using a parent thread by calling pthread create, so this is where you get the uh, child thread id. Okay, so this is the child thread id in the first argument. So what you want? You want to get the id of the child thread created. You want to get it through this argument by passing this argument. So how to do it? By passing an argument, how can I fetch a value? What do I need to pass?
Address.
Address. So the first argument, that's why it is, you see, this is a pointer type. So this is what I pass, and in return what I get, I get a child thread id. Okay, and this is attribute where I can have many options, and you can find it from the book by Stevens. One of them is attachable, detachable. There are many other options also, the scheduling priorities and all. So that you can fix. The third argument is also a very important argument. Can you figure out what type of argument or what type of information you want to pass here from the prototype itself? Can you decode what it means? Can you see this thread routine? There is a pointer and then this. So what is this? This is a function pointer. So this is a pointer to a function which accepts void arguments and which returns void pointer and returns void pointer. Is that fine? Can you recall the function pointers? Hello? Hello?
Yes, sir. Yes, sir.
Yes, sir.
So this one is clear. And what about the last argument? This one? What do you think should be passed here? If it is successful, you get the thread ID here. You can specify what type of thread, child thread you are going to create here, and many other important features. If it is default, you can set it to just null. The third one is a function, but what will be the arguments to the function? How to pass the arguments? So this is the last argument. So this is the last parameter where you pass on the argument on which this function will work. So you can even pass arguments like that. Okay. So when the thread gets successfully created, it will be a separate executable unit, right? Detachable, executable and schedulable unit. What it will execute? Whatever it is written in this function. What on which data it will work? The data that you pass here. Is that fine?
Yes, sir.
And so you have to basically write a function following this argument type, following this prototype. So the function that you want to pass as the action or as a logic to be executed by a thread should follow this particular prototype. And once you have done that, within that function, so you have to basically write a function. The function name can be anything, and so that function's address should be passed here. Now the point is, within that function which a thread is going to execute, we expect that pthread exit should be the last statement within that function. Okay, and within that pthread exit, if you recall the exit system call to terminate processes, in the exit what we can pass the return code or the something that is returned. And if you can recall it, if I write exit 1, so in the parent, when it synchronizes with that particular exits or with that child death, what it will decode, what value it will receive in the wait system call, through which if it synchronizes, what it receives, if the
return status.
Yeah, but what value? So if exit returns say 2, it will read it as 2 into 256,
2
right?
into
It will be shifted.
256. Yes.
Can you recall that? So it is something
Yes,
like
sir.
that. So here, if you call, if you pass basically return value, so the thing is, it should be passing the address. You see, it is not a direct value. So you should pass the address of a variable where the return value is kept, right? So if you are passing an integer value, you should declare an integer variable, and the address of the integer variable you should pass here. While when the child process terminates, by calling exit, you should pass the address of that integer variable, which actually contains the return value. Fine. So this part is fine. And then the
Sir,
parent
why is
process.
it
Yes.
void type?
Which one?
Why is the return value void type,
No,
sir?
void means it is generic type. So you do not know. Sometimes you will be returning a floating point value. Sometimes you will be returning integer value. Sometimes you will be returning a maybe a structure itself. So like that. So if it is a void type, so even if it is a structure or integer or float, you just cast it as a void asterisk and you pass it. And then when you receive it in the parent thread, so you then again recast it to that particular type, because you might be knowing, because a parent must know what the child has actually returned. So it will again recast it and it will unpack it and you will know the contents of it, right? Got it?
Yes, sir.
Because if you don't pass it as a void, then it will be restricted. If you write here the pthread exit only accepts integer asterisks, that means you can only return integer type values from a child thread, and that is a limitation. So to overcome that, it is mentioned as void asterisks. So any type of value can be returned, even you can return a structure or an object in general, like that. But because it is void, you have to typecast it, and you have to recast it in the parent thread after it has received it. Okay, till this point it is fine.
Yes, sir.
So now comes pthread join. So pthread join, who will execute it? The parent thread. And what are the arguments? So a parent thread may have created multiple child threads, right? So now, if you recall the wait PID, the system called wait PID, can you recall that? So wait PID, what are the arguments? The argument is which particular child process you would like to synchronize, that you can specify, and then you have to you can find out what it actually returns. So it was not exactly the same prototype, but here you can have both the option. So here you can specify which thread ID you would like to synchronize. Where from you get it? The one that you have received while creation. The one that you have received while creation, if you have stored it in an array, so from that, whichever thread ID you specify here, so this pthread join will synchronize the parent thread with that particular child thread's termination. And the second argument is the thread return. So whatever value that particular thread has returned by calling pthread exit will be received in this particular argument. And can you see that this is a void asterisk asterisk? Okay. So you have to, so first of all you have to pass here. So you have to pass here. I mean, you have to declare, say, a integer pointer, and you have to pass the address of that integer pointer to get the value. So that is how the prototype has been defined, and it returns int. If it is successful, it will return 1, otherwise 0, like that. So these are the points, and another point is here. Okay, so can you see this is a pthread underscore t. So what it is, what is analogy with respect to the process?
PID underscore T.
PID underscore t. So PID underscore t. I know that it is, these are all integers. Thread ID can only be unsigned integer, but still this is not treated as a simple unsigned integer. It's a special kind of ID which is used to identify uniquely a thread. Like so, instead of so it is not a process ID. It's a pthread ID. So it's a thread ID like that. And this one, as you can see here, this is in the second argument to set the attachable or detachable mode. You have got pthread underscore attribute underscore t. So you have got an attribute object. So in that attribute object, you have got certain say certain data members through which you define. So a particular thread is defined. Uh, the features of a particular thread, child thread, is defined by this thread attribute object. So pthread attribute underscore t. So that you have to declare an object of that type, and then using the dot operator you can specify the values corresponding to each feature. Okay, and then once you have so if you don't pass anything, the default will be taken. If you want to reset it to your according to your need, or define it in your own way ignoring the default one, you can declare an object of type pthread attribute underscore t, and then set the specific choices, and then you pass it here. You pass what? You pass the address of that attribute object. We'll see this in details, so I'm just trying to give you an overview of. And then once you have written a suitable function following the prototype, it will work. And then here you pass basically uh, you store it in a integer array, and you pass the address of that element, and that will be considered. So like that. So this is fine. So we'll see that how it works. So here this is one just example. So can you see the, can everybody see the example? Can you tell me what it is doing? So first thing you see, this is, so here we have included pthread underscore pthread dot h header file. So this pthread dot h header file will allow you to use all those library functions that we have just now mentioned for creating threads. So the point to note is, for creating threads or manipulating threads, we are not going to use directly the nptel say system calls. We are not going to use directly the clone, although we know that using the clone the same thing can be done. But it is not only the creation of threads is enough, but you have to also manipulate threads, you have to also synchronize, you have to do other things also in the threads, right? So for that it is not enough to just create the clone the thread using clone. So it is better not to use clone and to use pthread underscore create. So once this is this header file you have included, you are ready to use it, and there are three functions as you can see that we have used here. One is a pthread create and this pthread join. So there are two functions I have used, and what do we expect now? So as you can see here, if you focus here, so there is a for loop, and in this for loop I equals to 0 to 2. So how many threads, how many times this pthread create will be called?
2 times.
So this code is intended to create two child threads. So automatically this one, this original parent itself will be a thread, but at this point of time it will create two child threads. Okay, so as per the prototype pthread create, what is the first argument? The first argument should be a, what is the first argument?
So the thread ID, like.
Yeah, the address of a variable which is of type pthread underscore t, right? You see, this is pointer to that. So what do I need to do now? So you see pthread underscore t. Can you see this? Pthread underscore t. This is equivalent to pid underscore t. So we have created an array of two such objects which can hold thread IDs. Is that okay?
Yes, sir.
Because we know that pthread underscore t is the data type which can store thread IDs, and this threads is an array of two elements which can store two thread IDs, because my program intends to create two threads. And what I have to pass, so for each iteration I have to pass the ith element of that. So threads 0, thread 1, like that. So thread side is the value, but because it is so I am not, I have to receive the id, so I am passing the address of it, right? So that's why it's ampersand threads I. Is that part clear?
Yes, sir.
So what is the next argument here? The next argument is
Attachable thread or detachable thread.
yes. So null means it is the default value. So null means it is considering the default. And what is the default one? So default is attachable.
Attachable.
Okay. So if you set it to null, so it default is attachable, like that. Now what about this one?
The code it has to execute.
Yes, the function. So this thread code, there should be a function named as thread code, and it is here, right? And can you see that its prototype complies with the one that we have just now mentioned? So this function accepts void pointer and returns void pointer, and that is what is mentioned here. You see, it's a address to a function, within parentheses address to a function which accepts void pointer and returns void pointer. So we have defined we have defined and declared a function which complies with the interface of that
Sir,
function.
sir, but you didn't pass any argument there.
No, I'm not passing arguments here. There is no provision to pass arguments here. Only passing arguments in the last in this one, in the fourth parameter, as a fourth parameter. How can you pass arguments? So when you are passing function, when you are passing, say, the address of a function, you cannot pass the arguments directly there. It is not possible. So here you mention the base address of the function, the body that it was to execute, and in the last argument you are passing the arguments uh, that that thread code function will be utilizing during its execution. So is this part clear? The thread code, the function. Hello.
Yes, sir.
So what I have done here, it's pretty simple. So here, as you can see, so this last argument was what? Last argument was void asterisk. So it's a void type, void pointer kind of thing. So here what we did, thread arguments. What I did, thread arguments was here 0 and 5. So there are two values that I pass. In the first thread, I would like to pass 0. In the second thread, a child thread, I would like to pass the value 5. তন্দ্রি ক্লাসে আছি, পরে ফোন করছি আপনাকে। আজকে মিটিং বলেছিলাম নাকি, না কালকে বললাম? হ্যাঁ দেখুন তো, হ্যাঁ আমি কালকে লিখেছিলাম মনে, দেখুন একবার। হ্যাঁ Okay, sorry. So here, as you can see, thread arguments. So I would like to pass here integer arguments. So thread arguments. That's why I have considered a one-dimensional integer array and storing the value 0 and 5. So I want the child thread, the first child thread to take this 0 and the second child thread to take the value 5. So when I am passing, ठीक है, नहीं चले जाए, टाइम लगेगा. Okay, so while I'm passing here, I have to pass the address of that particular argument, or if it is stored in an integer, if it is stored in an integer variable, so I have to pass the address of that particular integer variable. Okay, so here when I receive it, you see, because it's a void type, so here I first convert it to what? I first convert the pointer to integer type because I know that it contains integers. So this is actually passed here. So this is actually passed here, but I have to first recast it to an integer type, and then ampersand means I get into that location to get the value. So this index in the first thread, it will get the value 0. The index in the second thread, it will get the value 5. Is that part okay? See, there is no provision to pass the arguments in the here itself. So I just specify the name of the function, the address of the function here, and in the last argument I am passing the arguments. So these arguments that I have, the address of the argument that I have passed will be actually passed, will be assigned to this particular local variable. Is that part okay? Hello.
Yes.
And because it is a void type, and I know the actual content is integer type, so the first thing that I do is I recast it to integer type. So now the pointer is recasted as an integer, and I give an asterisk to get the to get the contents in that space pointed by the pointer. So I actually find the value 0 or value 5, whatever. Any query till this point? So then what I do, I basically int s equals to 0. Then what I do here, so what is the intention is, here you see this is a global array, global integer array containing 1 2 3 4 5 6, whatever it is. Now we know that whenever we create a child thread, so the entire virtual memory will be shared, right? So the entire virtual memory will be shared, excepting what? Excepting the stack segment.
Stack segment.
So except the stack segment, everything will be shared. So the data segment will be shared, and this is a global array. So global array will be stored in the data segment. So the data segment. So here, if you if you consider this, the parent thread or the parent process, whatever you think. So it has got an array, which is a global array of size 10. It is in the data segment. Now it has created two child threads. Two child threads are created. Now each of them, they are having they are executing the same logic. So that's why it is thread code, and it is also executing thread code. Although they are using the same logic, function logic, but they are having their own stack, right? So they are having their own stack. So let us consider that they are having this their own stack. So using the stack, this function when it executes, it uses this stack, right? But because they are sharing the data segment that is there in the that you have that's a part of the parent thread process, or parent process or parent thread. whatever. So I mean, in fact, this parent thread, these two child threads, all they can access to this data segment. Okay. So this array, whatever we have initialized, is accessible to this. Now I want that this particular uh, this particular child process, child thread will be accessing only this much, and the other child process, so this will be executing only this much, and the other child process, that means this one, will be executing this much, the remaining of it. So as an argument, what I have passed, this starting, so that's why I passed 0 here, and for the second child thread I have passed the value 5, that means the starting of the sequence that need to be accessed by the second child thread. Is that part clear?
Sir, what is the advantage of using the functions of pthread library rather than using the direct system calls of NPTEL?
No, no, as I mentioned, so the so once you have got a standard library, function, a standard interface, then you are writing it for Linux. Now, if you use it in other implementation of Unix or other implementation of Linux, maybe Red Hat Linux or uh, some other Linux, or maybe AIX, IBM Unix, or maybe some BSD version, or maybe Mac OS. So your entire code is portable. So the same code is portable because if you know that they are also using pthread create. So if you compile that, if you compile your code, this high level code, so once they are using pthread create, so they know that how to compile it and how to create the threads in their own way. Are you getting the point?
Yes, sir.
So Linux might be using clone, but AIX or BSD BSD Unix, it might be using some other system call to create executable instance similar to a thread, lightweight process. So how you know that? So you have to then again use the same the system calls defined in that particular operating system, and then you have to do it. Hello.
Yes, sir.
So this pthread says that you are pretty happy. So you know the high level code is this. Now if you compile it in a AIX, IBM AIX, so it will compile and it will know that what is AIX's say system call, which creates something equivalent to a thread. It may not be clone, it can be something else, or maybe some different versions, whatever. You don't have to worry about it. And whenever you are running it in any Linux implementations, hopefully the clone is already activated in that, if it is beyond 2.6 kernel version, so automatically it gets implemented. So as a high level code, high level coder, or say if you are an application programmer who wants to write say multi-threaded applications, you just focus on your logic, your application logic and all, and implement the thread calls using pthread library, and you can be simply happy that no matter wherever you compile, if it is a POSIX compatible, POSIX compliant OS, it will work there also. And in fact, there are many implementations of Unix which are POSIX compatible, as you can see here. Can you see the POSIX threads are available? So POSIX threads are available in POSIX conformant OS such as FreeBSD, NetBSD, OpenBSD, Linux, Mac OS, Android, and all this. So you don't have to really worry about your high-level code uh, because you know these are very much dependent on the operating system also. The system calls that is there, and pthread is available from kernel version 2.6 plus in Linux. Is that okay?
Yes.
So now what next? So once we have created these two threads, one is this one and this one. So this is child thread 1 and this child thread 2. you know that they are running, and so they are basically executing this particular uh, function thread code, and they know what type of argument is there. Now what we are doing here is, so the first child process, a child thread, is basically adding all the elements till 0 to 4, and the second thread is basically adding all the elements in the array, in that global array, which is by default shared by both of them, starting from 5 to the remaining, right? And I'm just adding it now. S equals to S plus array. So uh, what is this? What is S? S is a local variable. So what is sum? What is sum? So my
Total sum of the
intention,
array.
yeah. So what is my intention? So the overall intention of the code, I mean, whether I have succeeded in doing so properly, I don't know. But the intention was the parent thread process, I mean the parent thread will read a global array and store it in a data segment. It will create two child threads, and it will ask those the individual child threads to add the elements of that array, a portion of that. So because of two, so it has divided into two equal halves, and each child thread is supposed to add all the elements in the first half and the second half, like that. Now so it basically, the overall objective is to add all the elements to get the sum of all the elements. That is the objective. But I want to perform the addition in two separate threads simultaneously. So it may seem very trivial, but I mean, this is just an idea that how you can parallelize the whole thing, because adding the first five will not going to impact the remaining five, the last five. So we can do it parallelly. But the thing is, you have to take the sum calculated by the first thread and the second thread together, and you have to again add them up. So how I do this? So the idea that I thought was to use a global variable sum, which is initialized to 0, and then after it has done, it will be writing sum plus equals to S. Okay, and then here it so sum plus equals to S. So and each thread will compute its sum, and it will update S accordingly. So do you think it is a perfect code? Will it really work at the end? If the parent thread, after joining, if it displays the value of sum, do you expect to get the value of the exact sum of all the elements? Hello?
No, sir.
Hmm? Yes or no? Will you get the exact sum?
Think
A
no,
simple
sir.
question. Yes or no?
No, sir.
A bit louder. So you got the question?
Yes, sir.
Now tell me the answer. Will it be correct or it may not be correct? No answer from any of you.
Sir, it
No,
will be incorrect, sir.
it's not correct.
Anybody who says it will be correct? Anybody who thinks that it may be correct? I mean, it may be, na? It will be correct always. Anybody in the class who thinks so? Now, who said that it is not correct? So why it may not be correct always?
Sir, in the index, like the for loop is going from index to 5.
Hmm.
So in the second thread that we are creating, so index is 5 there,
Hmm.
and then it will not run for any 0 times. So I don't think it will do the whole sum.
Okay, okay.
Well,
That was a minor mistake. So this is not. So
Uh,
I mean, yeah, I got your point, but that was a mistake. Anyway, so this you ignore. Okay, so let us assume that this part is correct.
Sir.
So accessing this part and accessing this part is correct. Yeah, that was a mistake. If that was taken care of, then
Sir, then it should be correct, sir.
yes, sir. All others, will it be always correct?
Sir, maybe it can be an analogy to account balance.
Yes. So what kind of problem it is? It's a race around condition. Why? That's the account. So this sum is now equivalent to that account balance, and you are trying to, so these each child thread, they are basically the clients, they are the account holders, and they are trying to update that shared variable, because now it's a shared variable, right? It's a default shared. The sum is a default shared variable, global variable, shared by multiple child threads. Now if you are trying to access, so when you are writing this part, you see, when you are writing this part, sum equals to sum plus equals to s, how many machine cycles do you require to get it updated? How many machine cycles do you require? Can you, huh?
Sir, 2.
Yeah, it depends. I mean, it may be more than two. I mean,
Like two
you are reading,
steps.
then you are updating, then you are writing back. So like that. So if there are multiple machine cycles, so in between two machine cycles, there may be interrupt. So the same
Sir,
thing say
because
for,
of scheduling, it might give
yeah,
an
you don't
incorrect
know.
value.
You don't know. Maybe the first child or maybe the last second thread read it, updated it, but before it would have written, the first thread read it. So basically both read 0. Now the first thread also updated it. Now it will be updated into its own value. Now it may happen that the second thread who updated it already in its own space, it is going to write it back. So it will be writing its sum, and after it has done, the first thread will be writing it back. So ultimately what you will get the first thread's value itself. Okay, are you getting the case? Hello?
Yes,
So
sir.
it may or may not be correct.
Yeah, I mean, that is what I mean. So it's better, I mean, we should say that there is a rest condition, and rest condition is never acceptable in operating systems. So something that you cannot, so definitely it is not correct, and if uh, the correctness cannot be ensured, this should, this is not a, this is not a correct code. So this code, so syntactically it seems fine that we are calling pthread create, and we are passing the arguments, and everything seems to be working fine, but the application as it suggests, that you are trying to get the sum and then update it in your own way without any control, without any synchronization primitive. If you would like to do that, the outcome can be undefined, and which is not expected. So but this example was just to illustrate how the thread function calls can be called. That was a basic focus, but even this simple code will not work for the purpose that we just now mentioned. So for that also, we need some additional piece of code. We need semaphores, we need some kind of synchronization primitives to work. Got the point? So these are very simple things. The problem can be very easily understood, and we need to have some additional code, some additional mechanisms to ensure that no matter what you do, whatever the scheduling is, they will always ensure the correct values. So for that, the next topic after the threads, will start process synchronization. We will see that how process synchronization takes place. So earlier we found that it was based on the function, based on the file, because in a process, the parent process and a child process, the file is trivially shared. Okay, if you create a child from a parent, the file handler, these are all trivially shared. So if it is shared, and if both wants to update the contents of a particular file location, then it will be a rest condition. In this case, two child threads, they are sharing the global variable sum, and that creates a rest condition. So there are, whenever there is a resource sharing among multiple executable units like threads and processes, that must be ensured, that must be controlled by some synchronization primitive. If you don't do it, it will be a the outcome can be unpredictable and it is not wanted. So for the time being, let us ignore that case, how I solve that problem, but let us focus on the thread syntax, the thread creation and all the issues that we are just now we are mainly discussing about. So up to this part, is there any question? Hello?
No, sir.
So now finally focus on the pthread join. So after creating the both the threads, the parent it will execute another for loop. And now if it wants to uh, synchronize with both the child processes, both the child threads, so it will be executing the pthread join twice, two times. So that's why within a for loop I have included pthread join, and it has got two arguments. The first one is you have to specify the thread ID for which with which you want to synchronize. So in the first iteration, it will be synchronizing with the thread child thread 1, the first child thread, and in the second case with the second child thread. That's why it is threads 1. So it is specifying the thread ID, right? Probably you can see. And this is null means it ignores because so in this case there is no pthread exit that was executed by the thread function. So that's why I've ignored it. So it is basically null. So I'm ignoring the second argument of the pthread join. So this code, even in this case, it will ensure that the parent does not proceed. The parent does not proceed, uh, say, before both the threads has completed its execution, because the parent wants to display the overall sum, right? Now if one of the child thread is not complete, there is no point it can retrieve the sum. So that's why so this thread join is only to basically make sure that the parent thread waits till the child threads complete. That's all. And once they do it, I mean once it joins with a particular child thread, it will say that okay, I have so in the main thread and child thread this has ended, so it will just give a prompt that okay, I have found that this thread has completed, this thread has completed, like that. So I guess this is fine. Hello?
Sir, when the creation of a thread is not successful, what will be stored in thread of I?
So here you see this is the return code will be somewhat null, -1 or something that, so that you can check in the thread library. So either it returns -1 or 0, that I have to check. So it's a good, always a good practice to see the return code. Pthread create it has not successfully created it. So you get the return value here and you say that assert, you can call assert to uh, make sure that it has returned the successful creation code. Okay. So for any system call or any library, that's a common practice. So you make sure that it has properly executed. Only then you proceed. Otherwise, you just stop. Let us hope that that part is correct. Anything else? Hello?
No, sir.
Anything that you want to ask here? Any doubt till this point? Okay, so can you tell me that at least for this very simple case, how can I overcome that problem of arriving to a race condition without using any synchronization primitives? By using pthread join, instead of passing here null, can I use pthread exit and don't use null here to get rid of the solution, at least for the time being? Have you got my question?
Yes.
Think of the solution. Everybody got the question? My point is I am not using pthread exit here, right? And because of that I am not using I am just using null here. So instead of updating sum like that, sum equals to sum plus s, can I do something else? Maybe I pass I call pthread exit and I actually retrieve the value here, so that whenever the child thread joins with the parent thread, the parent thread extracts the value that it has calculated. Hello?
Sir, we can do that, a temporary solution.
How? No, it's not a temporary solution. It is also a solution, but it depends on the application. So this application can be easily solved using that. So there are many ways. So this is unnecessarily the array. It's fine. It has got a global array, and you know that in a non-overlapping areas they are working, so there is no problem. And it's basically read-only case. So whenever it is read-only, there is no problem. But whenever you are trying to update a shared variable, write on that, read and write on that, then there lies a problem. So without doing that, if I mean, without that approach, if I do it in a different way, that is definitely it's a foolproof solution. But all the time, or for any other applications, you may not always have an option of bypassing the synchronization. So that is not always possible. But in this case, it is possible. So what to do now? I mean, what if we do? The result will be perfect. If I write pthread join, pthread exit, what I need to pass?
The exit status, the status code.
No, it's not the status code. What is that?
Address of the
It's a
Exit
return value.
code.
What value I would
Return
like to return here? The value of
the sum that we
s.
created s.
The value of
S.
s, right? The value of s. So what I need to pass here? Pthread underscore exit. Can I pass just s? What do I need to pass?
address of S.
Address of s. That's all. And if I do so, then what I need to do here in the null, instead of null I have to pass say if it is a result code. You see, it's a result code. Okay, so result code is for different use. I mean, I have to declare here in that case int asterisk um, say s or say x, and I pass here the address of x here. The address of x I pass, and from that I can decode. So the first time so now here I do that. So s equals to s plus equal to that x. So one by one it does. Is that part okay? Can you guess what I mean?
Sir, we don't have S in main function. We define
You don't
X.
have? Okay, no, this is not sum. This is sum. Sorry. So this is, so here what I do, sum plus equals to x, and here probably I pass here ampersand of x like that, and I have to declare x as integer asterisk. Got it? So you can try later on to see that whether it works or not. Fine.
Sir, in the function part, we have to use the thread exit.
Yes. Here you have to use thread exit. So here it is pthread. Just a minute. Here you have to use this one, and here you have to specify, declare here something int asterisk x, but you have to pass the address of x, because why? Because it is, you see, this is ampersand, is asterisk asterisk, this one. Got it?
Yes, sir.
You have to basically declare integer asterisk x, and then you have to pass the address of x, and then after that you write here sum plus equal to x, and then you can display sum here. Is that part okay?
Yes, sir.
Okay, I would expect you to try it of you in your own way, because and then see how it works, because uh, these are these are some codes which you have to actually run and see how it is working. It is not possible to feed each and everything. You have to do a bit of it of your own. But if there are any questions till this point, you can ask any doubts you have got, but you have to write it and see and make changes and all this. So can you see this code? So this code is exactly the same. There is no change at all. I have just commented this part, and the only change that I have made here is this one. What is this? What is this?
Creating 20 threads.
So I would like to make just 20 threads, that's all. And I basically ignore what I am doing here. Okay, so this, just ignore it, no matter what the threads does and all. So they, once the thread is created, it goes into an infinite loop, that's all. So this is basically infinite loop. This runs forever. So I have just used the same skeleton, that's all. I've got a different purpose to see here. So it runs for this runs forever, each thread. So once, so the parent thread, the parent creates multiple threads, right? One, then two, and three, 4, 5, 6, like this. So how many? 20 threads it creates. Now, and then it executes pthread join, right? So will this pthread join will ever be successfully executed? I mean, will this for loop ever gets completed?
No, sir.
Hmm? Will the parent thread will be ever be able to execute this particular line, line 34? Because the child threads that it has created, will they ever be completed?
No, sir.
So it will wait forever, right? So the
Yes, sir.
the parent thread will keep waiting for thread 0, thread 1, and nothing will happen. So it will basically get stuck there. That's all. And I want to really make them, I would like to force them to work forever. Okay. So what I want is the parent thread which actually starts, it should run forever, and basically it will get suspended for the child threads to die, and the child thread processes should keep on executing. So they are not suspended, right? So the child thread processes, they are basically executing the infinite for loop. So they are always active, doing nothing, but they are stealing the CPU cycles. They are utilizing the CPU cycles, right? So now the question is, how many logical CPU or the logical processors I have got in my machine? I'm running in my machine. So how many logical processors I have got?
4.
4.
4 processors. So logical, so LP1, maybe LP2, I may call it as LP3 and LP4. And I know that, so I've got a dual core machine. So dual core machine means these two logical processors hyper threading. So this is basically in a single physical CPU, and this is in a single processor. So processor 1, so I mean physical CPU 1 and physical CPU 2, like that. So I've got 4 logical processors. And how many threads I've got?
20
How many
threads.
threads I've got? Hmm? including the parent?
21.
21. So total there are 21 threads. Now each of these 21 threads, these are, you can call it as LWP. These are lightweight processes. Lightweight process means thread or lightweight process, basically the same. In Linux, the terminologies are the same, right? So the scheduler, the CPU scheduler need to schedule all these 21 threads to these 4 processors. And definitely there should not be any biasness and all this. So on an average, each CPU, how many threads will be assigned? Because all of them are willing to run infinite loops. So on an average, how many processors, how many threads are assigned for execution in a particular logical processor?
5.
Simple, they should be equally divided. So 5, almost 5, right? Hello?
Yes, sir.
Yes,
Sir.
yes, sir.
5. So now the question is, uh, if I look into the utilization of a CPU, CPU utilization means this, you want to check that how much time the CPU, a particular logical processor, remains busy, or what fraction of time it remains busy. What should be the answer, do you think? The CPU, it has been assigned 5 threads, not processes, 5 LWPs, lightweight processes, or 5 threads, right? 5 Linux threads has been assigned to a single logical processor. So do you think that it will be ever be sitting idle?
No, sir.
No, sir.
So what will be its utilization? Utilization of LP1, LP2,
100%.
LP3, LP4, it will be
Nearly 100.
nearly 100. Now can you see this from these values?
Yes, sir.
What I did, I executed top in a different shell, in a different terminal, and I pressed 1. I'll show it here now. I'm just discussing it. So when you press 1, you will get the breakup of each CPU. So CPU1, CPU2, CPU3, CPU4, you see all are nearly 100%. Why it is not exactly 100?
So system processes are also running.
No, none of the system processes are running. All you see are all are, they are all suspend. Is there anything running? I don't think so.
Sir, this is the
No, you
aggregated
see, no, no,
time,
see,
no,
see, no,
sir.
you should not wonder what is. So this is as simple as this. You see, is there any system processes? These one are running.
Yeah, no, sir.
No, sir.
So right now
Suspend.
nothing is running. Okay, but still it is not 100. Why it is not 100? What might be the reason? So these are all suspended. These are all suspended. One reason can be like 5
Sir,
threads are getting.
context switching time.
Yes, context switching time, because it's not that a particular thread keeps monopolizing its use. So automatically, what kind of scheduling there it is running actually in Linux? What is the scheduling algorithm?
Round robin.
Hmm?
Round robin.
No, not round
Round
robin.
robin.
It's a modification of round robin. It's not purely round robin.
Oh,
That's the wrong
yes.
answer. Huh? It's called fair share scheduling. Okay, I'll forward you the video that the video of my lecture that I took in the last year. So it is not round robin. It's some variant of round robin, but it's not round robin. It's not the way round robin works. But the effect is round robin. That's fine. But there are other nuances. Okay, so definitely, so the 5 you have assigned 5. So out of 5, maybe the number 1 gets executed, waits for a while, then preempted, then the second one. So this preemption time, so that you cannot make sure that it will be 100%. So that's why it is not 100%. Now the other question is, how much slice of the CPU time a particular thread enjoys? Got my question? How much slice of a CPU, how much share of a CPU time a particular thread is enjoying? So one physical process or one logical processor is assigned how many threads?
5 threads.
About
5.
5.
So if you have a uniformity of scheduling and fair share is indeed as no biasness is there, so how much CPU time slice they will enjoy?
20% nearly.
20%. So can you see this here? From here can you see? It's nearly 20%. Is this visible? This column, the CPU utilization, or the CPU
Yes,
share.
sir.
You see, they all are more or less the same, the 23, 24, but it's nearly 20%. Is that fine?
Yes, sir.
So what we intuitively feel, that is getting executed internally also. Can you have a feel of that?
Yes, sir.
So if you really write a code using the pthread create, which in turn calls clone to actually create LWPs, which are lightweight processes. And why it is lightweight? Because you see all of them, they share the same process ID. Can you see this? The process ID for all of them are the same, but they have their own individual LWP IDs. So these are thread IDs. And the executable, basic executable unit is this. The scheduler is scheduling each of these individual entities because they are tracked separately and they are maintained separately, they are scheduled separately. So without each of them, each of the LWP having the entire, the overhead of a process, they still are scheduled and executed simultaneously, and that makes the performance very fast. And if you can, so that's the reason why the performance may be made very fast if we write a multi-threaded application. And that indeed, in true sense, it exploits the presence of uh, all the four physical processors. I mean the logical processors. Is that okay?
Yes, sir.
Yes, sir.
So these figures show it exactly what is happening, and you see that this is total 7 so tasks. So it is 7 because task is, in this case the task is the process ID, right? So it treats that a single process is running here. You see, a single process is running in the application. And what are the other processes? 1, 2, 3, 4. So it's 1, 2, 3, 4, 5, 6, and 7. The top itself is 7. So there are 7 tasks, 7 processes. So task means you can say this is a process. What are the distinct process IDs? 7. Okay. One of them is the top. Another one is the original parent. Sorry, the original application process itself. That is 297, and within which you have got these LWPs created. So when it is getting scheduled, individual LWPs are getting scheduled in the processors, but the total number of tasks running is 7, and one is running. Which one is running? The one that we have executed. The application. 6 are sleeping, including top. Sometimes it is getting, it wakes up and executes and again sleeps like that. Can you decode the whole output? Hello?
Sir,
Yes, sir.
why top will sleep?
Why? No, top is, so top, it's periodically. So after every 5 seconds it flushes. It checks the status and it updates it. Now again it sleeps. Again it updates. So that is how the top works. So top, we'll see that how it works. So why it will sleep for a while, that we'll see.
The
So apart from that,
status
hmm?
the status is seen as running, no sir. Clearly there.
No, but I have not taken both the snaps simultaneously. Okay, oh, which one? So top is running. Uh, how many of them are sleeping? Oh, a dot out is sleeping. Okay, a dot out means the parent thread. The parent thread is sleeping. That's why you see this is denoted as sleeping. Can you see this?
Yes, sir.
So that's why it is sleeping. It says that it is sleeping. Any other question?
Sir, we have another class right now, sir, section X.
Okay, from 5.
Yes, sir.
What to do? Okay, we are more or less done. I would like I would have thought of showing the output these codes. Okay, I'll talk to the CR for the next class. Any question?